Greetings and welcome to Physical Science at Hack. In this video, we will work through the sample problems for Chapter 12 in our textbook on organic chemistry. So let's go ahead and get started. Our first problem is a calculation problem, and it asks you what is the mass of 20.0 liters of gasoline, and then tells you to assume that the gasoline is pure octane with a density of 0.692 grams per milliliter. So for problem ones, it's always good to write what we know. So we know that the mass is equal to 20.0 liters. And we know that the density is equal to 0.692 grams per milliliter. Now, one thing here we have to look at right away is that the units do not match up. We have liters for the mass and milliliters for the density. We have to convert one of those in order to be able to use this. So the easiest way to do this would probably be to, instead of writing this as 20 liters, writing it as 20,000 milliliters. So now the units will actually match up. Same amount of material, 20 liters and 20,000 milliliters, but we need them in the same units so we can actually use the density. Now, if we recall, density is equal to the mass divided by the volume. Or in this case, what we want is we want to find, what are we looking for? We are looking for the mass. So we have to solve this equation for the mass. So mass is equal to density times volume. So we know the density, and in fact, you can see I marked it wrong up here. I said mass. This is not the mass. This is actually the volume. So let's put that up there correctly. This is the volume is 20,000 milliliters. So now we know that the mass is equal to the density 0.692 grams per milliliter. And that is multiplied by the 20,000 milliliters that we have. Unit wise, the units will cancel, the milliliters will cancel here, giving us just a mass in grams. And we find out that if we multiply those, that the mass is 13,840 grams, or 13.8 kilograms. And we would want that to be three significant figures. Since both of our numbers going into this had three significant figures, our answer would be 13.8 kilograms for the mass of 20 liters of gasoline. So moving on to our second problem then. Our second problem asks what the molecular weight of Freon is. Now, Freon can also be called a dichloro-difluoromethane. So we have to figure out what that is. And if you recall, methane is CH4. So let's look at methane first. Is carbon with 4 hydrogens. Now, if we remember our terminology, this is methane, so it's going to have the same structure, except it's going to have dichloro, which means 2 chlorines, and difluoro, which has 2 fluorines. So the Freon, is going to have the formula of still have the carbon structure there, but is then going to have 2 chlorines and 2 fluorines. So now that we know what it is, we can get the formula of CCl2F2. So we know that this Freon has 1 carbon atom. Each molecule will have 1 carbon atom, 2 chlorine atoms, and 2 fluorine atoms. So now we can figure out the molecular weight, and we know that carbon has, let's write them up over in the side here, carbon is 12.0 units. We know that chlorine is 35.5 units. And there's 2 of those. And we know that fluorine is 19 units. And there are also 2 of those. To find the molecular weight, we just have to put all of those together. And that would mean 12 units, because there's 1 carbon, so 12.0 units, plus 2 times 35.5 units for the chlorine, plus 2 times 19.0 units for the fluorine. And if you multiply and add all that up, you'll find out it's 121 units for the molecular weight. And again, each of these had 3 significant figures, so our answer should have 3 significant figures. So 121 units would be the molecular weight of fluorine. Now, our third problem asks for a structural formula for ethyl alcohol. And we're going to need first the ethyl radical. Think about this. We need the basis for what ethene is, because ethyl alcohol would be based on that. So we want to know, remember what ethene is. We know what methane is. And ethane is going to have 2 carbons instead of just 1. So it's got a carbon bond there. And then it has hydrogen. So this is not our answer yet, but this is what we would have for ethane. Now, to make it an ethyl alcohol, what we have to do is replace, we want to make this an alcohol, we have to replace one of these H's becomes an OH. So that gives it the needed portion for the alcohol. So we would end up with, our answer would be, we start off with the ethyl radical, so we'd have 2 carbons, we'd have lots of hydrogens here, and we would then have the OH radical, so the functional group would be the OH there, and that would give us our answer that we would need. That would be the structural formula for ethyl alcohol. All we have to do is, because we're making it an alcohol, we replace the H by an OH. Now let's look at another example. Our fourth problem here. We'll have ethylene glycol. This is often used as antifreeze and has a structural formula given here. What functional group would this belong to? Well, if we look at that, we would see that that has an OH radical. So because it has the OH, then it would be, we see the OH here and another OH here. That would make it an alcohol. So this would belong to the functional group of the alcohols. Now our final problem, let's take a look at this, asks the compound heptane is C7H16. And we now want to know if that is saturated or unsaturated. And if you recall, saturated means that it is all single carbon-carbon bonds. There are no double or triple bonds involved here. So there are a couple of ways to do that. There was a formula that you could look at if this matched properly. That if this is N, if it's saturated, then this would have to be 2N plus 2, and that would make it saturated. You would have the maximum number of hydrogens you could, and there would therefore be no double or triple carbon bonds. Well, since N is 7 and 2 times 7 plus 2 is equal to 16, we can see that it is saturated. Now, if you don't want to do it that way, the other way is that you could sketch out the formula. There are 7 carbons, so we can draw those in here. And if it is saturated, then you would have 1 hydrogen. All would be single bonds, and you'd put in the number of hydrogens that you could get, and then find out, is this saturated or not? And if it's saturated, we're going to end up drawing in 16 hydrogen atoms on this molecule. And if we count them here now, as we draw them all in, there are, if we start here, let's start over at this one. So we'll start with this one. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that makes 16. So that is a saturated hydrocarbon. It has the maximum amount of hydrogen that it can possibly have, and all of the carbon bonds are then single bonds. So that concludes our video working through the sample problems for chapter 12 on organic chemistry. We'll be back again next time for the last chapter in the text and look at some problems on nuclear reactions. So until then, have a great day, everyone, and I will see you in class.